Good morning, ladies and gentlemen. My name's Duncan Brown. I'm the International Sales Manager for Verderflex, based out of the UK. Please don't hold that against me. I've been working with the guys here in Global Pumps for about 15 years, supplying the Australian mining industry. And I had a 2-year sabbatical that is probably quite relevant in mining terms. For 2 years I was running Verder's operation out in the high veld of South Africa, serving the platinum industry. So I'm not just one of these strange guys from the factory. I've also dealt directly with the end users in the mining industry. What I'd like to talk to you about today is not about a particular model of product, but to argue the case why you should consider pumping mining slurries with a peristaltic pump. The answer is less is going to give you more. When I say less, I talk about less water. On a typical thickener application, I'm going to save you over 1,000 million litres of water per annum. I'm going to use less power. Can save you 200 megawatt hours annually. Some big savings. We're going to require less space because we need less filter stages, and that means less land involved, and that feeds into less capital expenditure at the outset of a project. I'm going to talk about how we can help reduce pollution, because we're not a sealed technology, so the elimination of leaks addresses the issue of bad PR that always comes with extractive operations around the world. Similarly, because we've got a pumping action that allows us techniques like bio-oxidation to be used, we reduce the risk associated with some mining operations, because we're reducing the chemical usage, we've got less to store, so just simply the disaster impact is reduced. I'm also hopefully going to illustrate how we can use less processed chemical, and that feeds into a lower operating cost, but also a waste treatment cost at the end of the process, because we've not overused it, so we've not got to remove it at the end of the process. And finally, I'll show how we can lower the overall operating cost of a piece of equipment by reducing downtime and increasing the service intervals between pumps. And all these lessers add up to one thing, and that is more. And that's more money. It's more dollars, it's more euros, it's more yen, it's more yuan. The bottom line is it's all about money, and if we can help provide a better deal for the mining industry, then it's attractive for you because it helps improve your whole operating efficiency. So let's look at the first less, which is less water. Mining as a process is about turning ore into metal, particularly. We take big rocks from the underground or from the open cast sites. We take them into big ball mills, which turns them into powder. We add water to the powder to turn it into slurry, and then we treat it. And that is then treated and filtered and treated and filtered to liberate what we're really interested in, which is our precious metal, the precious minerals, and get rid of the valueless waste. Ultimately, when we're measuring our mining process, the key performance indicator is about the number of ore tons we can process on an hourly basis. The more we can push through, the more we get out at the other end, and that is about money. So, I've taken a fairly typical thickening situation, 75 tons of ore being processed an hour. If we look at how our traditional solution, a centrifugal pump, would handle that, it's good for about 30%, as Brad has already said. So that means at 75 tons an hour, we've got to add another 175 tons of water per hour. So our little yellow area of ore is matched with a significant amount of blue water, which gives us 250 tons an hour of slurry that we have to put through our operations. Now that assumes, first of all, that you've got water and it's readily available. A lot of mines are never in the ideal place for logistics. There's never a big reservoir or a natural lake at the side of the mine. If we look, the Northern Territory, it's a desert area. Antofagasta, the heart of the Chilean copper industry, is on the edge of the Atacama Desert. The Highveld in South Africa, it's an area where I know from personal experience it doesn't rain for 6 months. So water availability is at best questionable in a lot of these sites. And some of the water that's available isn't clean. So we have to add cost by conditioning it before we even take it into our process. So the more water we need, the more these costs adds up. And then associated with water use is the knock-on or the legacy issue. Because when we finish using that water, what do we do with it? You get issues like acid mine water drainage. In South Africa, there's a massive push about the green economy plan. For many years, South Africa, partly because of its historical background, used to quite happily put its waste out of sight where nobody could see it. But now they've discovered, hey, most of the water around Johannesburg is polluted, and it's rising up very close to groundwater levels. There's now a pressure on the mining industry to clean up after itself. And the real fact is, no matter where we are in the world, those pressures are going to increase over time. So the more water we use, the more we've got to treat after using it. And this is just processed water. We're not talking about flushing water or gland water. And the ultimate question is, can we reduce our water usage? Well, if we take our 75 tonnes an hour and put it with a hose pump, like the big green beast you'll see outside, those hose pumps will happily work with 60 to 80% solid content. Just to make my maths easy, I picked a conservative 65% solid. I haven't gone to the absolute best case, but with 65% solids, I only need to add 35% liquid, and that equates to 40 tonnes of water per hour. And I don't need flushing water. I don't need gland water. The bottom line, the hose pump is requiring about 1/4, 25% of the water that we need for a slurry pump. What does that mean annually? On 24/7 production, 50 weeks a year, which is the ideal goal for every mining operation, the slurry pump is going to use over 1.5 million tonnes of water per annum. The hose pump on the same 75 tonnes an hour application is 350,000 tonnes an hour, significantly less. What it equates to is it's a saving of over 1 million tonnes of water, or over 1 gigalitre of water annually. If I use what I'm told is a fairly conservative water cost of 15 cents a kilolitre here in Australia, those savings are over $175,000 annually. A massive potential benefit. But there's other potential benefits too. I can take it to the limit and max those savings out. This is a real project, kind of leaning back on my 2.5 years sabbatical out in South Africa. We took the limit. We went to 80% solids. Our water usage was about 19 tonnes an hour, 164 million litres per annum. That's about 90% saving on what we'd need for a centrifugal pump. The bottom line was over 200,000 Australian dollars saving in water costs. And this wasn't applying the Sky scheme. This is the world's largest platinum concentrator for Anglo-American, or Anglo-Platinum as that division operation is. It's Potgietersrus Platinum on the outskirts of Rustenburg in the Highveld of South Africa. It's a real project, and you can see the thickener, and you can actually see the VF125 pump physically in use. It's one of a pair because there's 2 on each thickener, duty and standby. That's just the case for water. But what about one of the other precious commodities that we have in the world of the mining industry that is always a key infrastructure consideration, and that's power. typical pumping heads are around about 5 to 7 bar. Our centrifugal pump, which is going to need 250 slurry tons an hour to handle our 75 tons of ore, is going to be flowing at over 200 cubic meters an hour. On typical conservative efficiencies of about 67%, I'm going to require 71 kilowatts. The hose pump, and I can read this straight off my performance curves, doesn't need 250,000 slurry tons an hour. It needs 115, or about 70 cubic meters an hour. And in that situation, we're absorbing 35 kilowatts from the motor at peak power. What does that mean? I've saved 36 kilowatts, which can be used elsewhere in the plant if power is scarce. If I was just looking at absolute savings, it's over 200 megawatt hours annually. At 10 cents a kilowatt, that's $30,000 straight to the bottom line. So there's an attraction there. All these can be combined to make the case. I mentioned that there's a space consideration. Because we increase the solids content, we've got a higher quality product going into our downline operations, which means we can reduce the number of post-thickening filtration stages. Less filters means we need less land. Less land means we've got less land to buy from the outset. So capital cost saving, number one. Capital cost saving two is if I save just one filtration stage, a typical disc filter is 100,000 US per stage. So there's a bottom line. So less initial investment, but with the same return, improves our return on investment. This is not about pumping technology, it's back to accountants and money. And unfortunately, the undead occur everywhere. So less space can give us a money saving. Mining uses some horribly nasty chemicals in its extractive processes. Cyanide, strong acids. They're the nature of the beast that we have to use to extract our minerals. But the problem is, a teaspoon of 2% cyanide will kill you. Now that creates a problem if we have a pump with a seal, because inevitably at some point a seal will leak, and a leak means we contaminate something. If we're very lucky, it's just an immediate abundant area around our plant. But I know of one particular concentration on an incident where the mine was at the top of the hill and the farm was at the bottom. The cyanide leak followed gravity and killed all the cows. That gave the mining company concerned two issues. One, a very annoyed Afrikaans farmer who used some very strange words and wanted compensation. But more damaging for the mining company concerned, it was bad PR. And bad PR always works against you when you want to expand your mining operations. So if we can mitigate that by using pumps like the hose pump and also the mag drive that Manfred will talk about in a few minutes, because they're sealless pumps, we eliminate the risk. If we can eliminate the risk at source, that means we've got less pollution. Less pollution is less bad PR, and potentially that could even reduce the delays when we're wanting to expand. And just to put the consequence of pollution in context, the picture is not of a mining horror story. It's actually a piece of English news. There was a leak from a metals processing factory in the UK, in the Midlands. It leaked out at 1 parts per million, but it polluted 20 miles of one of the main rivers in the UK, and it took 7 to 14 days of remedial work to restore the river back to its natural balance. That is just an example of the consequence of a small amount of weak cyanide solution. So if we can mitigate that risk, it helps improve the mining process. Similarly, the inherent pumping process in a peristaltic pump is one of the lowest shear pumping mechanisms available. it's very kind, and that allows us to use techniques like the Biox process developed by Goldfields, and that allows us to use a biological solution to break down refractory sulfide oils to get at the gold and dramatically reduce the amount of cyanide we're using in the process. We're reducing our cyanide usage, so the potential of a big leak is mitigated because there's less of it in the first place. So our gentle pumping action promotes the use of live bacteria techniques that allows us to advance the extractive technology. But also, as part of the process, you have dosing galleries where we're adding accelerators, concentrators, frothing agents, flocculants. A lot of pumping solutions are what we call high shear. And the key with flocculation is to maintain the size of the particle, because the bigger the surface area, the more efficient our flocculation process works. But the problem is, many traditional pumping solutions are high shear. That a screw pump particularly will create a high shear effect on our particle and will reduce its size. So we go from the ideal solution of the blue particle down to the much smaller red particle with a high shear solution. That's much reduced surface area, so the only way we can keep up our throughput is add more chemical to basically overdose our situation. Flocculants are expensive, it's a cost. It's also a residual that goes through the process because we don't use it efficiently, and we go to the tailings dam to retreat it. In contrast, the hose pump is a gentle, low shear solution. So, for some strange reason, I've used a green colour for the hose pump because it's the Verderflex colour and also Global Pump's colour. We maintain our particle size to about 90% of what we originally started with. That means our surface area is maintained. That gives us a flocculation system that runs as performed and reduced chemical usage. The bottom line is that less working chemical is less working damage, is lower chemical usage, and also less tailings reprocessing cost when we look at our residuals. Another potential hidden benefit. And lastly, there's the lifetime cost issue. Impellers on slurry have lives that in some situations you measure in a number of days, 10s, maybe 20 days. The solution has always been to go to hardening the metals, looking at exotic steels, but fundamentally the issues remain of abrasive wear, and because of the process reagents that you're using in your process, sometimes corrosion. Sulfuric acid isn't the nicest liquid. A peristaltic pump is totally wear resistant. You have inherently the best rubber-lined pump that's out there because the liquid is totally contained inside that nice rubber hose. And those rubbers can be made of different chemically resistant compounds. So we have some that handle paraffin that you see in the copper industry for pumping crud. You have EPDM rubbers that are better on sulfuric acids. You have hypalons where you have a mix. And hose lives in these situations are not measured in days. Practically, they're in months, and I'm not talking 1 month, I'm talking typically 3 to 6 months. The hoses can be changed where the pump sits. It's not a case of extracting the pump to the workshop. It can be changed in place where the pump sits, and the typical cost is about 15% of the pump's original investment. So by doing that, we're lowering the ongoing running costs, and that feeds in to lower lifetime operation costs of your piece of plant. So to summarise, I hopefully have illustrated the case that less is more. It's less water, the 1,000 million litres saved annually. It's less power. We can save 200 megawatt hours annually. That can be used elsewhere in the process if we're under power rationing or we're having brownout considerations because we're running the plant at its limit. We've got less space, which can reduce the filter stages and have a direct benefit on mining ROI. We can help reduce pollution by eliminating sources of leaks and the consequent bad PR that come with contamination of non-mining properties. Because we have less chemical, we can lessen the risk. We can also use bio-oxidation techniques, so initially our chemical storage areas are reduced. We can contribute by using less processed chemicals by having a gentle pumping action, which equates to lower cost and less waste residual processing costs. And lastly, hopefully we've illustrated that you can lower your operating costs by reducing downtime and having much lower ongoing spares costs. How that all adds up? It's more dollars, it's more euros, it's more yen, it's more yuan, it's more renminbi. The bottom line is, it's money, and that's what mining industry is about.